In this video, we show how to find the distance between 2 points in a plane. Suppose we've got 2 points, say P1, P2 in a plane. How to find the straight line distance, say D, between these points. Recall from the Pythagorean formula that if you have a right triangle, there's a relationship between the side lengths of that right triangle. And the relationship is that the longest side of the triangle, which is usually represented by C, is related to the other sides through this formula here. So in the same way, we can form a right triangle using the points P1 and P2. If we extend a horizontal line here from P1 and a vertical line, this box indicates a right triangle. All right, now this side length right here of this right triangle is the horizontal distance between point P1 and P2, and it's given by the difference x2 minus x1. In the same way, this side length right here is the vertical distance between points P1 and P2, and it's given by y2 minus y1. So you can see how we might form a relationship between D, the side length x2 minus x1, and this other side length y2 minus y1. So we can say D, given more specifically as the distance between points P1 and P2, is equal to this. Right? Now, let's look at some examples using this relationship. Say number 1. Suppose we got to find the distance between points say P1 at 6, 2 and P2 at say -4, -3, right? So they're asking us to find a distance. They gave us 2 points. So right away, we can apply our distance formula. But we first need to know what is x1, what is x2, what is y1, what is y2. Now, if we call 6 x1, then 2 must be y1, and -4 has to be x2, and -3 has to be y2. Another assignment that will work is to assign 6 as x2. In that case, 2 would have to be y2, and -4 would have to be x1, and -3 would have to be y1. But we definitely cannot have 6 as x1 and 2 as y2. This would not work, right? We have to be consistent with the subscripts or the numbers, the values, how we're assigning x1 and y1, right? So the first two assignments would work. And let's look at the first assignment, right? So I want to find the distance using 6 as x1 and using 2 as y1, and so on. So to find that distance, let's first write the formula. We're just taking our time. It's easy to make a mistake if you just throw numbers in. If you have the formula and you can see the formula, that you're taking your time. You're less likely to make a mistake, right? So let's first write the formula, then right underneath it, we can put the values in, right? It's okay to write a lot. Just take it step by step, and then you're less likely to make a mistake. So x2 we said here is -4. Minus, because there's a minus in the formula itself. And then x1 was 6. y2, -3. Minus from the formula. And then y1 is 2. Here we get -10, -5. Simplifying further, we get 100 plus 25, which is 125. All right, now 125 can be simplified a little bit more. 125 is 5 times 5 times 5. So one answer we can get from this is 5 square root of 5, right? This is an exact answer. An approximate answer from using a calculator, you can get 11.2 if you round to 1 decimal place or to the nearest tenth. Some textbooks or some questions that have multiple choice answers, they might have an answer choice that only has an exact answer in it. So that's why it's useful to know how to write the distance as an exact answer or as an approximate answer. All right, let's do a second equation, practice problem. Suppose this time the question is to find the length of the line segment. Right? So let's say they're going to give us a line segment. They don't give us points this time. They give us a picture. Doing my best to make these coordinate plane look accurate. All right, mark off some values here. Right. Let's say the point goes from here down to, say, here. Let's say it goes sort of like this, right? Just a segment like this. So here's the problem statement. Find the length of this segment. And by length of this segment, they just mean the distance. We want to find the distance of this segment. So immediately we can apply our distance formula. But we're going to need to know what is x1, what is y1, what is x2, what is y2. Right? So the first thing is to identify the endpoints of this line segment. So let's say this endpoint here, let's call this endpoint P1. And we can see that P1 is located at, looks to be at -2, 3. And P2 here is located at 3, -1. All right, so when we substitute these values into the equation, what are we going to have? So x2, okay, we can call this, let's call this x2, y2, x1, y1. Then we're going to have here 3 minus a -2 plus -1 -3. Simplifying, so we got a minus of a minus, that makes a plus. So 3 plus 2. Just taking our time so we don't make mistakes. So here is our final answer, and this an exact answer. It can't be simplified any further. But you could use a calculator and get an approximate value, which is 6.4 rounded to the nearest 10th. All right, that's it. If you found this video helpful, like and subscribe. Also, check out our website in the description below. Math is order. It's not just about numbers and symbols. Find out those things bringing disorder in your life and see if they can be ended.